like to introduce the paper which is tracking by instance detection or meta-learning approach. The tracking problem is closely related to the detection problem, and it even can be treated as a special type of object detection, which is we call instance detection. The major difference is that object detection locates object of some predefined classes, and its output does not differentiate between inter-class instances. But object tracking only looks for a particular instance. If we consider each tracking target as a category, the tracking tasks can be built as an instance object detection problem, then how can we apply an object detector for tracking tasks? In the previous research, some object detection techniques are used extensively in object tracking, CNN-based visual object tracking into two categories, which are template-based method and template-free method. First of all, template-based methods usually run fast because the CNN used to extract the features does not need to be online updated. However, as the tracking proceeds, new target appearance should be integrated into the template for a better performance, but most methods lack on effective model for template online updating. This limitation has created a performance ceiling for template-based trackers. The other category is template-free method, which is intended to store the target appearance information within the neural network in the form of fine-tuned parameters. We find that template-free trackers are a proper solution. However, it is still quite challenging to achieve a good performance speed trade-off for this type of trackers. So the main challenge is in designing template-free trackers is how to obtain a good initialization of the detector once a new instance is given, efficiently infuse the instance information into the network without overfitting. The greatest challenge is the lack of training data for object detection. The categories are predefined, so a larger amount of data can be collected to channel detector. But in object tracking, the target is given by user. We cannot collect the training data in advance. It means that their only training the image is used to channel the detector. So a common solution for lacking data is pre-training and fine-tuning. Basically, SGD is adopted to pretend the detector's weight. The pre-training pipeline is quite simple. However, it can not work well by tuning. We can see that detector granularly converges only the training image, but they fail to detect anything in the testing on, which means their loss of SGD pre-training is not capable of robust generalization. In this work, we would like to build a connection between these three tasks of the tracking can be built as object detection coupled with meta-learning. Model agnostic meta-learning, which is MAMR, is an important algorithm and supports the network to run a set of good initialization parameters that are suitable for fine-tuning. During training, the parameters of the model are explicitly trained such that a small number of gradient steps with a small amount of training data from a new task will produce good generalization performance on that task. In the isolation, this paper also performed a new step gradient distance only training images, but instead of directly updating, the paper introduced another set of images for validation. Each updated parameters will be tested only for validation images. The theta I and 1 is updated to minimize the loss of only validation images, but not only training images. Even with this free training and fine-tuning application, is to transform a detector into tracker in 3 steps. By such method, memory pre-training can achieve a good generalization capability in not only a fast converges only a training frame, but also performs well on the testing frame. First, we compare our method, which are two constructed memory trackers with the SOTA trackers on benchmarks in OTB dataset VOT 2018 and TrackingNet and LASSO. Numbers in red and blue are the best and the second best result respectively. In conclusion, this paper shows tracking can be viewed as an instance of object detection based on this idea. This paper proposes to use meta-learning that bridges the gaps between object detection and object tracking.